made available to everybody. That will go out probably within about 24 to 48 hours after the session is complete. There is also an opportunity for you to ask questions in today's session. How you do that is just how you've actually just confirmed the audio. Just use the audio portion, and then basically you can ask a question. We won't read your name. We won't read your, we won't read your company. We won't read anything like that. So what we'll do is we'll simply read the question out loud and we'll do our best to answer it. If we don't get to your questions, there's a lot of questions. Sometimes in these sessions there are. What we'll do is we'll create an FAQ document and make that available to everybody after the fact. With that said, we want to go ahead and jump right into it. So brief pause. We're going to come back on with the recording started and get the session kicked off. Okay, I want to thank everybody for joining us for today's Designing Labware Solutions for Maintainability and Scalability, featuring Ed Peliquin from the Astrix Labware Delivery Team. Next slide, please. So a little bit about the company, Astrix Technology Group. Before we get into today's session, Astrix is an informatics professional services and staffing company that's dedicated to servicing the scientific community. A couple of quick statistics on the company before we get into the content today. Firstly, Astrix has been around quite some time. It was established in 1995 and is privately held. It had originated as the IT division of a company called APBI, which is a $300 million life science research organization. Today, it operates from 8 offices around the country and about 500 employees. Its headquarters are in Red Bank, New Jersey. There's 2 primary divisions of the company. The one is the staffing division, which has private and public staffing, predominantly of scientific and IT resources. And then there's the professional services division, which is who you're speaking with today, which is focused on supporting science-based organizations and their technology needs, particularly in regulated laboratories. Target customers for the company are going to be folks that are in life science enterprises, government research institutions with large and fast-growing IT and compliance needs. The mission has always been to deliver scalable and sustainable solutions in IT and staffing for the scientific community. Next slide, Ed. So the company foundation, essentially what it's built on, is that we help clients excel and solve very complex problems with people and technology. There's really kind of 3 pieces to this. There is the science, the business, and the technology side. On the science side, it's really a focus on staffing folks with high degree of capabilities and expertise with scientific backgrounds. So there's practical bench experience available for companies with very broad subject matter expertise. And then on the business side, there's the laboratory management, the laboratory operations, and then managed services. It's a very broad scope with the company in terms of helping folks not only implement technology, but manage them after the fact, and even helping manage things like the setting up of the laboratory management operational structure. There's also creating value and trust in the business of science. This is really with specific laboratory applications that there's expertise in, and industry standard development database tools that we bring to bear for companies. Next slide, Ed. Everything is based upon the Astrix approach, which is a complete life cycle service from planning through implementation and managing. We deliver digital transformation to the lab through end-to-end professional services. We break this out through the plan phase, the implementation phase, and the management phase. Astrix in particular has great expertise in helping labs select the right technology for their needs. And then after they help implement, train, and support it, it's helping to manage that after the fact. So again, there's really a dedication to the entire life cycle. Next slide, Ed. And I believe at this point we want to get a sense for who's on the call. So we're going to launch a poll real quick. It should be popping up on your screen in just a second. This is going to talk a little bit about what your role relative to Labware is. We ask everybody to participate in the poll. Basically, what we're trying to find out is who's on the call today. We use this information for one purpose and one purpose only, and that is to determine the type of content that we want to continue to provide going forward. We usually leave the poll open for about 60 seconds or so. So go ahead and take a moment to answer that if you can. We'll share the results with everybody. Again, no privacy, no private information is shared, no email address, anything, or names or anything. We'll just share the results so you can kind of see what the mixture of folks on the call is today. So we'll leave it up for about 10 more seconds. And we're going to go ahead and close it out. And we'll share those results with everybody so you can see 54% is on LIMS administrator. That means we're presenting certainly the right content to the right people, which is great. And then we, of course, have a pretty even spread amongst the development and technical and the lab management side of the fence. So thank you again for participating in that poll. And with that, I am going to actually ask Ed to come on, and you're going to take over for a little while here, Ed.
All right, great. Hear me all right, Kevin?
I can hear you perfectly fine. Thank you.
All right, great. All right, so first, before we get started here, I just want to personally thank everyone who took the time out of their day to attend this webinar. It means a lot to me. I've been working with Labware now for about 14 years. I've worked for, in manufacturing companies, global life sciences, and some contract labs. I've been to several different industries. Personally, whenever I do work for a client, I really try to deliver the value to them. I try to balance the solutions that I deliver to be, easy to maintain, scalable. That way, it just, it ends up giving them more value out of the system moving forward. So with that being said, the reason why I chose this webinar, so this content, maintainability and scalability, the reason why I chose it is because it has particular importance to me. My background was from IT, so I wasn't actually from the lab. And one of my roles as the LIMS administrator for the company that I worked for, I was also 24/7 support for it. So it was sort of in my best interest to design solutions that were easy to maintain, that didn't cause me a big headache every time we had to adjust to a new business need. So I thought this was a good topic to talk about because I think that by focusing on the two aspects of this webinar, they can really improve the lifespan and the usability of your system. All right, so what we're going to learn today, what we're going to talk about specifically is some practical tips for implementing solutions that are focused on maintainability and scalability in Labware, okay? And I want to emphasize here that the examples that I'm going to share, that they are the low-hanging fruit. They're practical tips. They're not meant to be crazy complicated because I want to make sure that with the limited time we have that you really get something from this. And also, we're also going to mention, the best practices for ensuring the system remains maintainable and scalable. So getting there is one challenge, but then moving forward, there's another challenge to make sure it sort of stays that way. Right? Okay, so just an overview of Labware. I saw the majority of the people on the call here are LIMS administrators, so I'm not going to spend a ton of time here, but Labware is one of the largest information management systems. It's used by over 1,000 customers worldwide. It offers LIMS and ELN in a single package, which is pretty powerful. You don't have to spend time with a complicated middleware solution to make the LIMS work with the ELN. It's extremely flexible and configurable, which, as many of you are probably aware, that can sometimes lead to specific challenges. Right? You can do a lot of things with it, but if you're not careful, you can get yourself backed into a corner. And so those are the kind of things that I want to highlight today and hopefully give you something to take with you. All right, so before we dive into talking about each of these aspects, I just wanted to quickly define what they mean. So maintainability is the ease with which a software system or component can be modified to correct faults, improve performance or other attributes, or adapt to a changed environment. All right, so these are going to be your, your new business requirements come up, over the life cycle of the system, and you want to make sure that the system can handle those changes. And then scalability, the capability of a system, network, or process to handle a growing amount of work, or its potential to be enlarged to accommodate that growth. So this one, goes hand in hand with maintainability, but this one's really about, hey, we want to add another site. Yesterday, we thought we were going to be doing 1,000 samples. Now we're doing 10,000. We want to make sure that the system can handle the growth. All right, so what can happen if we don't focus on this? All right, so if we don't focus on maintainability and scalability in our system, it can lead to several things, right? Sometimes more severe than others, but here's some examples. So you'll have difficulty adding or modifying master data. So depending on the design of your master data in your system, it could be very challenging to add new tests or new products in the system. Maybe your tests are named very specifically; they're not generic. So you have to duplicate, quite a bit of, formulas, calculations, components. It's all duplicated every time you need to add a new test. So that makes it challenging. Defects that are hard to identify and correct. So this one is of particular interest to myself. So I find quite a bit that, especially in large teams, you'll have code throughout the system or functionality that sometimes gets duplicated. And it makes problems, like you think you fix a problem in one area of the system, and you didn't realize that maybe in another part of a system it was, similar logic was put in there, and that half of the system was not fixed. Decreased system efficiency and reliability. Increased resource requirements for future enhancements. This one's an important one because if your system isn't just inherently designed to be maintainable and scalable, if you want to add a new piece of functionality to your system, it can be very prohibitive, right? The analysis time required to figure out if the solution will work will increase, and then you run into more risks because you may have what they consider spaghetti code and other things that are duplicated in the system that'll make it more challenging to add future enhancements. So difficulty supporting additional roles and locations. This one's a big one, especially locations. I've seen LIMS systems that were designed for a single site, and then all of a sudden they acquire another site, and then there's a big problem because the LIMS was never designed to handle more than one location. And then difficulty supporting more dynamic data. So this is where you've got today you've got when you go live, maybe you've got a couple lots in the system or a handful of samples, but then maybe after a year or two you've got thousands of samples in your system, and what worked great to start with doesn't work so great now. Right, so Kevin, I think this is where you do your poll.
Yes, we are ready. So thank you for that. We are going to launch another poll. Which of the following issues have you experienced in your system? So let's go ahead and get that launched for everybody. Should see that in just a second. Should pop up on everybody's screen. Again, we'll probably keep it up for about 60 seconds or so. So take a moment to read the questions, and we appreciate everybody's participation. About 30 more seconds, we'll keep it open. All right, we'll go ahead and wrap that up. And just so everybody can see the results, you're seeing 28% future enhancements that are more resource intensive. Pretty even, neck and neck then between defects that are hard to identify and decreased system efficiency. And then coming in last is the difficulty adding master data. And then finally, supporting additional roles. So thank you all for that participation. Ed, we'll go ahead and pass it back to you.
All right, so what we're going to do now is we're going to talk about some specific tips for ensuring maintainability in your system. I've chosen the tips in this section specifically because I think they are, some of the most important things you can do, and they're pretty straightforward. So I think you'll get a lot from this. All right, so first thing, master data represents the static data in the system. So I just want to clarify that, but I'm pretty sure most people on this call already know this. But master data is very, very important in any LIM system, but also specifically in Labware. As you're well aware, the master data in the system, everything touches that. Every piece of functionality in your system revolves around the design of the master data. So making sure that the design is right has very large impacts moving forward throughout the lifecycle of the system. So the first thing I wanted to talk about is analysis naming conventions. I'm personally a big fan of generic naming conventions. So for example, if you have an assay test, name it assay. Maybe avoid naming it something very specific. Room 7 assay is just an example I made up. And the reason for this is because if you have a generic analysis, you can use product specifications and variations to drive the behavior. You don't necessarily have to duplicate the analysis to get the desired effect. In some cases, you may have an analysis and then a specific variation of that, which may only differ with units or something very simple, just like some reported names. And so by making use of generic analysis naming in combination with product specifications, you can achieve the goal without having to duplicate all the calculations and the components and whatever else went into making that specific version of the analysis. This will reduce the overall amount of static data that needs to be configured. You just overall won't need as many analysis definitions in the system, and it helps ensure uniformity. So you just don't have assay, version 1 calls a specific component one thing, and then the second version of assay calls it something different, unless you just want to control the way it's reported, in which case the product spec can handle that for you. All right, the second thing is when you're using an interface, like for example, Empower is a very popular one, you should group your analysis so that you have a raw data analysis and then you have a separate summary analysis, which is usually a parent test. The reason why you would do this is because, for one, data integrity, which is very important, is if you bring over results from another system and they come into a raw data test, and it's automated either through the Empower interface or LabStation or however you bring in the results, that test can be auto-authorized and it can be locked down. So that means that an analyst or someone else won't have to touch that data, in which will promote the data integrity. It's also good because if it's on a child test and you need to rerun it or add another replicate, you're not duplicating all the calculations and things like that. It's in the summary. So having your interface data come into a separate raw data test is very useful for ensuring maintainability. Thirdly, try not to base your naming conventions on another system. I notice this quite a bit. LIMS, more often than not, is not the system of truth. Your product specs, your analysis are usually defined in an EDMS system or some other system where they're documented. And a lot of times, there's a tendency to name the object specifically for the system that is the source of truth, and this can be problematic. I've seen in several cases where the document management system or whatever system that controls the naming convention for your master data is changed. And so that causes confusion moving forward because then you've got products and other types of data in the system that are named after something that no longer exists. So what I like to do is, when you design your LIMS, name your objects something that makes sense to the LIMS, and add a field for a reference for whatever the source of truth is. So maybe, for example, you have on the product table, its name is product A, but in EDMS it's called 1, 2, 3, 4, 5, 6, 7. So add a field to the product table that says X underscore other system name or X underscore EDMS ID. All right, that makes it much more flexible, much more scalable moving forward, and easier to maintain because you don't have to create or modify products or existing master data every time another system changes. All right, so similarly, and just building on the last tip, try not to tie your metadata to a name. Meaning, if you have products in the system, try not to associate maybe if it's a finished product or raw material by putting that right in the name, okay? Because then what ends up happening is your code or whatever functionality that maybe depends on a given product type or something else you end up with a lot of hard coding because you have to parse the names out to figure out exactly what you're dealing with. Instead, add a field for that. Metadata should always be, or whenever possible, broken out into separate fields. That way it makes it, more useful to report on, and, it keeps your keys, more anonymous, basically. Like you're not driving system functionality based on a name, you're driving it on the associated metadata. Number 5, custom and tables and fields should all start with a prefix. This is a simple thing. And this is pretty much a Labware standard. If you're adding custom tables and fields, you should always add a prefix. In the example here, I use X_table name, but it doesn't have to be X. It just generally should be something that is recognized by your organization. I've seen C, I've seen G, it just depends. But in this example, X_table name, and then if you're adding fields to an existing table, also prefix those fields. Although it is important to note that if you're adding a custom table, you do not need to add the prefix to the fields in that table as well. Just having one on the table itself is sufficient. If you're adding a bunch of functionality to the system that's related, you should consider adding an additional prefix to help group that stuff together. So in this example, X_CDR table name what that represents is this table belongs to the centralized data review group of functionality. Okay, so next I'm going to talk about some naming conventions. Naming conventions are important for a number of reasons, primarily for ease of finding what you're looking for. If you have like a large group of developers, sometimes it can be difficult to find existing functionality that may meet your needs for a new business requirement without enforcing a naming convention. I mean, there's systems with thousands and thousands of subroutines. It makes it very easy to write something that may already exist. So I just put together a few here. This is not an exhaustive list, but you should strive to name your routines so that you can tell what you're dealing with without actually having to open it up for the most part. So in the first example, there's MNU_LM_short description. So if you look at the key to the right, you can see that MNU stands for menu and LM stands for lot manager. So the developer automatically knows that this subroutine is called from a menu in lot manager, and then it does whatever the short description says. So like I said, in a large team, this makes it really handy to find what you're looking for without having to debug the code or do a code search for something specific. And I give some other examples here as well. So FN_short description, that would be a utility function. It can also help, can certainly help reduce duplication of logic. And it can be especially helpful in systems where the configured objects number in the hundreds or thousands. Okay, so next we're going to talk about coding standards. Right? It facilitates quicker development time, easier troubleshooting, and increased readability. So coding standards is a very large topic. So I've taken just a few of the things that I think are the most important to add here. Having consistent headers and comments, making use of snippets. So in Labware, it has the snippet functionality. It makes it very easy to help developers keep up with an agreed upon coding standard because they won't have to write things from scratch all the time. Headers and comments is a good example of this because whenever you create, a new routine in Labware, you just use the header snippet and it just gives you a template to fill out. But the same can go for, the same can be true for functionality that it just is used commonly throughout the system that you want to make sure is consistent. You can create your own snippets. So if there's a specific way that you want, variables checked for, make sure they're not empty, make sure they're numeric, you create a snippet for that. And so that ensures like developers on your team have an easy time meeting the standards that you've agreed upon. Headers should state the purpose, inputs and outputs, revision history of the routine. So, for troubleshooting, it makes it easier to see, what is this routine doing? Who's modified it? What does it expect as inputs? What is it going to give me as an output? Comments should state what the code is doing and then when necessary, why it is doing it. So this is sort of a common sense thing. You should be commenting any custom code in the system. This increases maintainability because you can understand. Sometimes the code is not, inherent. It's not inherently obvious what it's doing, and so the comments really do help. I know, just, like many of you probably do, you come back to something that you put in the system a year ago, and you have no idea why you did that. And so I find that comments are helpful, especially in those cases if you have a specific piece of functionality that may be confusing, or there's a specific reason you put it there, and it may not be inherently obvious later on. So using comments are important. Variable naming conventions should be meaningful and consistent, right? So Labware, uses LIMS Basic as its internal programming language, and it's not, the variables themselves, their data types are inferred at runtime. So it's very useful to have a naming convention for those variables to help developers tell what it is they're dealing with. For example, using in the next line, B return status, S return message. That's a Boolean. B return status, S return message. Well, that's a string. So you should be able to look at variables in the system and just tell what the data type is. Standardizing outputs is something that I personally am in favor of. It makes it very useful to have a standardized input and output, or standardized output methodology put in place for your routines in the system. So you can always use that to your benefit. If you call, let's say you didn't write the routine, but it's in the coding standards that your routines will have a standardized output, that you can make use of that throughout the system. So you always know that if you call a routine, you're going to get this as an output all the time that you can use to control, the flow of the logic. Go sub versus subroutine. I saw we had a lot of LIMS administrators on the call, so this one here is just a pet peeve of mine, and since we have a lot of administrators, I'll just touch briefly on this. Don't use go sub in the system everywhere just because it's a keyword. This can have a very negative impact on performance, and so just the point is here, be careful when you use these specific things. So if you're using go sub is really designed to be used in loops or in places where your code is going to be called over and over and over again in the same routine all the time. Subroutines should really be used in conditional logic. So if you're not going to call it 100% of the time, use subroutine. I've run into cases where you've got a menu routine in the system, and that menu routine calls one subroutine with go sub, and in that subroutine there's 18 go sub calls with 500 lines of code in each one of them, and it's caused problems. It's caused Labware to run out of memory or other bad things. So be careful when using these things and know why you're using them. Routine length and short circuiting. So as far as coding standards go, having agreed upon, size limit for subroutines or other logic in the system is very helpful. It's very difficult to maintain code when the subroutines are thousands of lines long. It makes it hard to read, and it's very error prone. You should really strive to keep your code size to a set length. Let's say 300 lines. I know it's an arbitrary number, and it may not always make sense, but keeping that, an agreed upon, hey, if we have a subroutine that's going over this many lines, we should consider breaking it up into some smaller routines. And then short circuiting, what that means is, don't put an if statement in your code where the whole routine's logic is in that one if statement. And if if whatever the condition is for it to continue isn't true, then you don't do anything. Just check that at the beginning and return, because then you run into a case where if you have to add more logic later, you're adding more and more nested ifs, which makes it harder to maintain that code. So try whenever possible to short circuit the code by checking the things that would cause it to not continue first, and then continue on afterward. And then consolidate core and shared logic into their own routines. All right, so this one's a biggie. I see this everywhere, and it's very common. You have a large team of developers, and it makes it very easy for people to be working on similar things and, not always know what each other is working on. So getting back to the naming convention, that helps with this. But what I'm specifically talking about here is, let's say you need to send emails in your system. And I've seen it where, okay, it's very easy to write a routine that sends an email for the specific purpose. Maybe you want to get notified when something is out of spec, so you send an email. And then they want another email when something else happens in the system. And so then what you end up with is a couple different routines that do the same thing, just their message is slightly different. So a better approach would be to have like a email sending routine where its behavior is driven based on the inputs. So you can pass in like an HTML template file path location for the email, the to list and the subject, and so don't try not to duplicate that, because then moving forward, if there's some change to the email functionality in the system, you're going to end up having to fix this in multiple places. And so this is one of the challenges that speaks to meeting new business requirements or resource intensive future enhancements, is because of this, a lot of times because of this duplication or hard coding. There's some hard coding as well. And this reduces the testing effort. If your core logic is consolidated, it's much easier to test. You're not having to test multiple pieces of the system to determine if that logic works. Okay, so here's just a screenshot of a snippet, right? So most of you may have already seen this before, but I just wanted to highlight it, that I was creating a new subroutine here, and all I did was use the snippet button at the top, which is the little, should have circled it here, but the little blue equal symbol with the parenthesis next to it. You click on that, and you can add the snippet right in and stub out the whole routine. So you can just start coding at the bottom. So this makes it very easy to enforce coding standards without having to write this from scratch every time, which would be very tedious. Okay, so let's see how we're doing. All right, so next we're going to talk about scalability. And so scalability is one of those things that is very hard, sometimes, very hard to determine up front. So for example, you're designing your LIMS system or you're implementing a new piece of functionality, and the solution that you put in place works great today, but maybe a year from now, it may not work so well, and it wasn't easy to identify that up front. So a good example of this is like maybe you've got a drop-down where the user picks a lot name. And it works great right now, but maybe when there's 10,000 lots in the system, that drop-down may not be working as fast as it used to be, right? And again, master data design. It is I think the most important factor in a scalable system. If your master data design is not scalable, it makes it very difficult to add more sites, add more users, more roles. If your naming conventions are very specific, it causes you to have to update code maybe unnecessarily, just when you could have avoided that by keeping things more generic. So be judicious with customizations. I've been asked over and over again, Ed, can you basically add the easy button that will do all of X, Y, and Z at the click of a button, which is great. But what you really need to be careful about is adding that type of functionality is great, but you have to make sure there's a business case for it. Just because you can automate it, sometimes maybe it might not be such a good idea to do it. It might save maybe it takes you a long time to build a piece of functionality that, really it's getting rid of one click or two clicks in the system. And then you're adding risk unnecessarily. So, and, increased customization can have an impact on performance. Vendor support, it's harder for Labware sometimes to identify maybe an issue you're having because of a particularly complicated piece of customization you put in the system. So the point here is, if you're going to add customization to the system, just make sure that there's actually a really good business case for it. You can always add something later, but it can, you should start with the 80-20 rule. Put in what you know you need, and then later on reassess it. Always strive to keep configuration data-driven, no hard coding. So this is just a pet peeve of mine here. Use custom fields and tables. Labware is very flexible. It lets you pretty much, do whatever you want. And you should always strive to keep data that is going to be driving decisions in the system out of the specific keys out of the code. For example, if product A is a finished product, then do X, Y, and Z. Well, how you determine that, you could put in the code literally check to see if this specific product is a finished product based on, if it's FP, do this, if it's RM, do this, or you can make that data driven by having like a lookup table where you can keep that that decision making out of the code, or the actual keys out of the code. This reduces regression testing too. So adding a new rule, you don't have to go in and modify, or you just know that the code is still going to work because there's no hard coding involved. You can tell just by looking at the configuration what the behavior will be. And also makes enhancements faster. Enhancements and bug fixes much faster. There's less coding involved when you make your configuration data-driven. Be mindful of dynamic data. All right, so the example I talked about earlier, and I'll just touch on it again here quickly, is it's very common to have a drop-down list or a multi-list or something that is presented to the user to select something. Commonly, it's a lot name, or maybe they're choosing a storage location or something like that. You have to be very careful with that type of functionality, because if you don't spend the time to filter the results, over time, those decisions may come back to impact performance. Also, because you can add fields to Labware, and it's very easy to do so, be mindful of indexes. It can be worth your while to get with a DBA or somebody that can help you analyze the way that your data is being queried and help you put indexes in the database to speed up those queries. It's not uncommon for the sample table in Labware to be several hundred columns or a couple hundred columns. And so, making some functionality that queries a field on there that isn't indexed can be very expensive down the line, maybe in a year or two. Okay, so now I want to talk about just some specific examples of things that I've done. All right, these are simple things that you can do to increase maintainability and scalability. All right, so one of my favorite things that I like to do is site-specific business rules. So Labware has a very good mechanism of implementing business rules, but they're global. So they have things like, can you review your own results? And there's a whole bunch of business rules in there out of the box. But a lot of times those rules will need to be overwritten depending on certain situations. So Site A may enforce one rule where Site B may not. And so what I found to be a good way to handle this is to create a site business rules table. So in the screenshots that I have here for Site A, we can see that we have our business rules grouped into sections or tabs at the top. So you've got inventory settings, environmental monitoring settings, stability, and so forth. You can do this any way you please. But having the rules defined here and not having it in the code makes overriding the default system behavior in the status rules much easier. You look up the rules here and you don't have them hard-coded. This makes your system very scalable. So you add another site, you come to the site business rules table, you configure the rules for that site, and then there you go. The new site is ready to go as far as the rules are considered. You don't have to do any coding. You don't have to open up any status rules and add another site key in there. You could just pull it directly from the database. The next example I want to talk about is location-specific variations. All right, this just came up recently, and I just thought it was interesting. So the original design in their system was that you get the variation from the product spec, which is a very common way to do it. But a lot of the business, a lot of the testing is done, outside of the local sites. So they use contract testing organizations to do some of the testing. And when the testing is done at these locations, a specific variation is needed. Well, we could just open up the code and put some code in there to say if it's, if the testing location is in this example, testing location A, then use variation, whatever it happens to be. But you can see how that would impact maintainability and scalability, because if you ever have this problem again with another location, you're going to have to open the code and make another rule. So the solution that was implemented here was to expand on the out-of-the-box locations table and add some child tables to it. The screenshot on the right, the select dialog, you can see that we have location test methods and location test variations. So having that location test variations and methods child tables enabled us to configure a specific variation for that location. So in this case, for assay, they want to use the micrograms per milliliter variation if it's tested at location A. And obviously, there's a routine in there at certain events during the system to check which variations should be assigned. But this is a scalable way that you can implement an override to what the system thinks it should be doing by default. The location test methods, I added it here for reference just so you could see what was in that table. This client specifically was using this table to determine which test methods a specific location they were able to import results from automatically through an interface. So along the same lines here, we've added it to a table so we didn't have to code that anywhere. All right, assigning multiple test methods. Here's another good one. So in a system, you have tests assigned to samples, and a lot of times a client will want to capture which specific test method they're going to be using for that specific test. And the specific problem here was that they needed to have more than one test method assigned to a test. So then you come to the classic problem. Well, do I just add another column to the test record? Add, test method 1, test method 2, test method 3. But you can see how that would go against the principles of scalability and maintainability, because you would have to add a new column for every test method that could be assigned. So the solution that we implemented here was a child table off of test that allowed you to define any number of test methods for this test. So you can see on the screenshot on the right that has like the sample number, the sample name, test number, the analysis, and then it has the test method and the specific version of that test method that is assigned. And so you can quickly see that in the left screenshot. If you select that sample or test in the system, you can quickly view the assigned test methods using an icon rule at the bottom, the black T in the white box. So by clicking that, you can open up all the assigned test methods. So we avoided the need of adding multiple fields to the test table by breaking it into its own table. All right, so now that we've talked about some specific tips for ensuring maintainability and scalability, how are we going to enforce it? So that's what I'd like to talk about next. Okay, so the first thing I'd like to touch on is having a system architect, or the importance of it. Having somebody that is just in charge of the overall design is very important. It should be separate from the system owner, and it should be, but ideally it should be somebody with a business stake in the system. It should be somebody that is an employee of that company. This will ensure that the overall configuration adheres to the set standards, especially with distributed teams. So where it gets challenging, especially with larger companies, is they tend to hire people to come in to help with a specific project, but then they leave, and then maybe in the future somebody else comes in and does another project. Having the system architect there as part of that company will help standardize the design choices throughout the development and maintenance lifecycle of the system. Design documents are another great way of enforcing maintainable and scalable solutions. Having SOPs that clearly outline the rules for naming conventions and shared functionality is very helpful. So where naming conventions can help, sometimes you can't name something in the system that might be super obvious. So having design specs and having SOPs can really help for future enhancements, because it can help the developer find what they're looking for, and it can also explain to them how the existing functionality works. Design documents should also utilize a consistent design template. So this makes it easy for someone who is reading them to know what they're looking at. They don't have to figure out how the document is structured each time for every different one. They should all look consistent so they can quickly navigate to what they're looking for. It enables new resources to get to speed much quicker. And they help explain, what was done and why it was done. Okay, so code reviews. Code reviews are another great way to ensure your system is maintainable and scalable. Even the best developer will make mistakes. So having a second person or a group of people review your functionality can really help, find things early. Because you can test it with a test script, but sometimes the test script, you catch different things when you review the code. There may be something, the code may technically work, but you may see something that might be a problem in the future. Ideally, your system architect will participate, but sometimes I know that's not feasible, but it is a good idea if possible. Code reviews don't always catch design issues. So that's why it's also important for the architect to be there. The code could be good, it could be clean, it could be maintainable, but it may not meet the overall design of the system. It can be a good way to identify duplicated or subpar logic, get rid of dead code. I can't tell you how many times we've had code with a breakpoint that we didn't realize that was in there. And so all of a sudden in production, users are getting a breakpoint. So a code review can catch that sort of thing as well. Missed error traps. Maybe you've got this, like I mentioned earlier, a routine that's several hundred lines long, but really the whole thing could be avoided with an if statement at the top instead of having all the logic in the in nested if statements. So in summary, ensuring maintainability and scalability in your system can result in easier to manage master data, defects that are easier to identify and correct, or maybe not if you do it right, which is almost impossible, but you never know. Increase system efficiency and reliability. It makes future enhancements that are less resource intensive, and it does that because it standardizes the way that you implement solutions. It keeps decision making out of the code and makes it more configurable. Better support for larger volumes of data. So if you're at 100 samples now and 10,000 next year, by focusing on that early can make you prepared for that when it's time. It can increase your return on investment and increase user acceptance, which is really important, right? You don't want to have your users constantly frustrated with the way the system is, the way it works or the way it's performing. And then Kevin, I think we got another poll.
We do. Can bring that up. Okay, just give me 1 sec here and we'll go ahead and get that launched. You should see it up on your screen in about 2 seconds. So which of the following webinars would you like to see in the future? Obviously, we want to keep presenting information that's interesting and that you find valuable. So by all means, share with us what you're interested in. We'll leave this one up for a few seconds. I know we're at 150 mark, so we want to kind of move through the rest of this pretty quickly and get to see if you guys have any Q&A. So about 10 seconds left. We'll leave this up. All right, great. All right, we'll go ahead and end that. We'll share the results. So 40% migrating legacy system data into Labware as number 1, benefits of an ELN within the LIMS architecture. 2, benefits of systems integration. And then finally, specific topics you would like to learn about. So we will end that, and we appreciate everybody's participation in the polls this afternoon. Back to you, Ed. Ed, you okay?
My mic was up. Why Astrix? So you should choose Astrix for your, to implement your solutions. We have extensive experience servicing the scientific community. So not only do we have people who specialize in Labware, but we also have a lot of complementary areas of expertise. We have project managers. We have other people that manage other aspects of the LIMS system. So, your Empower, project management, BAs. So we bring a lot to the table in regards to, supporting a wide variety of needs. And one thing that's, very important to me is when when we're contracted to help you with your specific situation, we like to design and implement for the long term. So we want to take a look at your issue. We want to make sure that the solution that we provide isn't just good today, but it's good for it's good for the life of the system. And so that's really an important point to make. We have a proven implementation methodology, and it's designed to reduce risk, which is what I've really been talking about this whole time. Not only was I trying to focus on maintainability and scalability, but in doing so, you're really going to be able to reduce the risk in whatever solution is that you're trying to do. And so I think that wraps up the webinar, but I do want to thank everyone again for attending, and I do appreciate everyone's time. And I hope that you were able to take something useful from this, even if it was small.
And we thank you for that great content and really deep dive into some of these topics. I want to remind everybody that if you have specific questions that have come up during the session, we're happy to field them right now. If you don't have any questions, that's fine. I want to make sure everybody's aware that we will be sending out a copy of the slides. That's one of the questions that's up here. Actually, a few of the questions are asking that. Yes, everybody will get a copy. It will be in PDF format. It will go out via email, hopefully by tomorrow afternoon. So just keep an eye out for an email from Astrix, and you will have that. And certainly, if in that email, if you'd like to talk a little bit more deeply about your own Labware implementation, or if you have any specific Labware questions you'd like to talk to somebody over here, there'll be some contact information in that as well. Before we disconnect, I don't see any other questions popping up here throughout the session. There was a few regarding the poll, why you couldn't have it as a multi-select, and I appreciate that question. Unfortunately, we have some limits with polls regarding Citrix. It only allows you to select one, so we can't control that setting, but good bit of feedback, and we'll definitely put that through to our friends at Citrix and see if that's something they want to consider. One thing I would like to point out to everybody is that Astrix produces each year a LIMS survey. We basically go out and we ask a series of questions, and we take the information that comes out of this LIMS survey and we basically put it into a format of a research report, and we make that available to everybody. I'm going to put that link to it in the chat. And you'll see that it's a SurveyMonkey link. If anybody's interested, we are giving out $25 gift cards for a select number of folks who participate in that. So by all means, you're welcome to take probably about 8 to 10 minutes tops, go through that, and you have a shot at winning a little gift card. And obviously anybody that participates, we'll make sure we get you a copy of that LIMS survey as well. So we thank you for your participation in that. Other than that, I'm not seeing any other questions come up on the board, Ed, so I think we could probably wrap today's session up. And, again, thank everybody for the time that you provided to us this afternoon. And again, Ed, thank you for taking time to create such wonderful content on this topic. So, Ed, we can go ahead and I guess wrap it up.
Okay, thank you very much.
Thank you.